Okay, so here we go. So the first section is all about simplifying radicals, okay, in one manner or another. First one, you're just simplifying the radical. I look at the number, the square root of 24. Okay, well, that's the square root of 4 times the square root of 6, which is 2 root 6. So I have 2 square root of 6. That's strictly the numeric portion alone. Now I start looking at the variables. G of 7. My index is 2. 7 divided by 2 is 3 with a remainder of 1. So I pull out g to the third power and leave g to the first inside. So it's g cubed, g to the first. And then I look at h to the fourth. 4 divided by 2 is 2 with no remainder. So I pull out an h squared and I don't have any h's left behind. H squared. 2g cubed, h squared. Let me write that a little neater. 2g cubed, h squared, square root of 6g. Okay, second problem, we want to combine up like radicals. Currently they're not, but they can be simplified. For a hint, I look at the one that cannot be simplified at all, root 3. Does 3 go in any of those? Yeah. 27, square root of 27, square root of 9, square root of 3. 3, that helps me find it. So that's 3 root 3. So I have 3 root 3 plus, and then we've done the square root of 12 several times. Square root of 12 is 2 root 3 minus root 3. They're all root 3s. So I have 3 root 3s plus 2 more root 3s. That gives me 5 root 3s, and then I take 1 root 3 away. That leaves me with 4 of them. 4 root 3. I have 3 bananas, get 2 more bananas, and then somebody takes one of my bananas. That means I have 4 bananas. Same thing, only you use root 3s instead of bananas. Okay, they're all the same. Number 3. Not allowed to have radicals in the denominator. In order to get rid of the radical in the denominator, multiply by the conjugate. 7 plus the square root of 2. Excuse me, exactly the same except for plus root 2 instead of minus. Take the numerator, FOIL it out. 3 times 7, 21. 3 times root 2, 3 root 2. Root 2 times 7 plus 7 root 2. Square root of 2 times the square root of 2 gives me 2. Over. My denominator, ooh, it's the conjugate. There's a shortcut. Square the first one, 49, minus square the second one, 2. Negative square root of 2 squared is 2. Combine like terms and simplify. 21 plus 2 gives me 23. 3 root 2, 7 root 2 plus 10 root 2 all over 49 minus 2 is 47. Can't do anything else to that. Questions? Okay, next one, FOIL it out, combine up like terms. 3, ooh. Oh, though I do have, this is a conjugate situation, right? Square the first minus square the second. Okay, it might be that on the test, it might not, so let's go ahead and FOIL it out as if it worked like that on your test coming up. If I were to FOIL it out, instead of using the shortcut, 3 root 7 times 3 root 7. 3 times 3 gives me 9. Root 7 times root 7 is 7. 3 times 7 is, or sorry, 9 times 7 is 63. So when I multiply these two, I get 63. 3 root 7 times negative 2 is negative 6 root 7. 2 times 3 root 7 is plus 6 root 7. And then 2 times negative 2 is negative 4. Your middle terms drop out. 63 minus 4, 59. which is what technically happens here when we do our shortcut. The middle terms drop out. Square of the first minus square of the second. That's what happens here. That's exactly what happened here. Square of the first minus square of the second. Square of the first doesn't look like a perfect square, but that's because it's a combination of numbers and radicals when you square. Okay. Any questions before the next page? Okay, rational exponents. First one is simplified. That means I'm going to have a single number, no radicals, no exponents. That's my final answer. First thing I like to do is take care of the negative. So I have 1 over 16 to the 3/4 power. Now I like to take care of the denominator, take care of the roots before the power because it makes my numbers smaller. So the denominator 4 in the denominator means I take the 4th root. 4th root of 16 is 2. 1 over 2 cubed, which is 1 over 8. Write as an exponential. That means get rid of the radical. Okay. So 4th root means it's a 4th power, which means it's a fraction with the 4 as my denominator. That's what the 4th root means. So I take whatever the powers are, put them over 4. That's a to the first, so I now have a to the 1/4, b to the 5/4, c to the 7/4 power. Easy enough. Number 6, write it as a radical. Same idea in reverse. Everyone has a 5 in the denominator. That means I have a 5th root. My power of my whatever I put underneath that root is whatever the numerator is. So I have 3 to the first, x to the 7th, y to the 3rd. Now the next one is interesting. I have a couple of steps that I need to do to number 8. So I'm kind of working out a numerical order, which you guys can follow along. So I have some interesting things I can do that. I have options. I can go ahead and raise everything to the 2nd power, or I can simplify inside the parentheses first. I actually prefer to simplify inside the parentheses first. And go ahead and leave negative exponents for now. We'll get rid of the negative exponents on our final step. Okay? So, a cubed divided by a to the first. I subtract the exponents. 3 minus 1 is 2. So I have a squared. B to the negative 3, b to the first. Negative 3 minus 1 is negative 4. Negative 3 minus 1 is negative 4. So I have b to the negative 4th power. And then I have c to the negative 5 in the denominator. But I don't have any fractions here. I don't want any fractions, so I take that c, and if I move it up to the numerator, it's going to become c to the positive 5. All I did was what was inside the parentheses. I have not done anything else, but I simplified inside the parentheses. Now, that's all still taken to the negative 2 power. Okay, when I raise a power to a power, I multiply the exponents. So I multiply negative 2 times every one of those. So I get a to the negative 4, b to the positive 8, c to the negative 10. Negative 2 times 2, negative 2 times negative 4, negative 2 times 5. I'm not done because I need to have no negative exponents, but it's easy now. I just take the ones with the negative exponent, put them in the denominator, make them positive, and leave the positive ones in the numerator. So that means I'm going to have b to the 8th, a to the 4th, c to the 10th. Now, is that the only way I could have done that? No. I could have raised everything to the negative 2 power inside the parentheses, negative 2 times every exponent. and then combined them up, and then got rid of any negatives in my final answer then. Would have worked just fine. Still would have gotten the same answer in the end if I did it right. I prefer to simplify inside the parentheses, then raise them to their powers. If I can do it. That's what I prefer to do. It's not the only way to do it. Okay. And then last but not least, first question, what is d to the 0? 1. So this becomes irrelevant. Now I just raise everything to the second power. 5 to the second, b cubed to the second, c to the negative 2 to the second. 5 to the second power is 25. And then I get b to the 6, c to the negative 4. But I'm not allowed to have negative exponent in my answer. So the c to the negative 4 moves to the denominator, 25, b to the 6 over c to the positive 4. Questions? Okay. Solve. Step number 1, get the radical by itself. Add 8 to both sides. Square root of x minus 3 equals 3. Radical equal to everything else. Get rid of the radical. In this case, square both sides. X minus 3 equals 9. Add 3. X equals 12. What do I need to do? Check it. Make sure it works. 12 minus 3 is 9. Square root of 9 is 3. 3 minus 8 is negative 5. That one works. Next one. Get the radical by itself. It is. Next, get rid of the radical. In this case, it's a fourth root, so I need to take it to the fourth power. So I get 4x minus 5 equals 2 to the fourth is 16. Right? 2, 4, 8, 16, yeah. Add 5. 4x equals 21. Divide by 4. X equals 21 over 4. And then what do I have to do? Check it and make sure it works. 21 over 4 times 4 is 21. 21 minus 5 is 16. 4 through to 16 is 2. Es bueno. Next one. First step, get the root by itself. Add 5. Square root of 2x plus 13 equals x plus 5. Step 2, get rid of the radical. 2x plus 13 equals, square it out. Either use the shortcut or do x plus 5 times x plus 5. You get x squared plus 10x plus 25. Set it equal to 0. To set it equal to 0, you want your x squareds to always be positive. X squared is positive, you can factor these. Subtract 2x, subtract 13, subtract 2x, subtract 13. 0 equals x squared plus 8x plus 12. Two numbers that multiply to give me 12 and add to give me 8. 6 and 2. 0 equals x plus 6, x plus 2, x plus 6 equals 0, x plus 2 equals 0, which means that x equals negative 2 and x equals negative 6. And then I have to try them and see if they work. Now, I know you're thinking, oh, you have a negative equal to something, the square root might not work, but there's other stuff there, so you do have to check. Take negative 2, plug it in. 2 times negative 2 is negative 4. Negative 4 plus 13 is 9. Square root of 9 is 3. 3 minus 5 is negative 2. That one works. Negative 6. 2 times negative 6 is negative 12. Negative 12 plus 13 is 1. Square root of 1 is 1. 1 minus 5 is not negative 6. Usually when you have this situation, one works, one doesn't, but you never know for sure. You must check them both. Okay? I might just make it sneaky on the test and give it where both don't work or both do work, and make those lazy people that check one and assume the opposite is true for the other side get it wrong. I've been known to be like that. No guarantees. Questions on this? Moving right along. Evaluation time. Find f of 2. F of x is 4x plus 2. Took x, replaced it with 2. So f of 2 is 4 times 2 plus 2, 10. Right? 4 times 2, yeah, 10. Find g of h of f of 3. Work from the inside out. Find f of 3. Okay, f of 3 is 4 times 3 plus 2, which is 12 plus 2, 14. So I'm actually looking for g of h of 14. So I need to find h of 14. So 14 is negative x plus 1. Negative 14 plus 1 equals negative 13. So this is really g of negative 13. And g is 3x squared. So that's 3 times negative 13 squared. Okay, negative 13 squared is 169. 169 times 3. 3 times 9 is 27. Put down the 7, carry the 2. 3 times 6.
Negative 507.
Negative 16. So what you got? Yeah, there's a 0. And I'll take your word for it on the last one. Sorry, I'm trying to work it out in my head. It's positive.
How?
Negative 13 squared is negative 13 times negative 13 to give you positive. Oh, my Lord. Yes. So when you typed it in your calculator, you put negative 13 squared, and your calculator took 15 and squared it and then applied the negative. If you put parentheses around the negative before you square it, it'll square the negative number. Gotta be smarter than your calculator. Yeah, apparently you're not. Very common mistake. You just have to get used to it. I don't make that mistake anymore because I've been doing it long enough. I don't make those mistakes. And you also have to understand intuitively, I'm taking a negative and squaring it times a positive. My answer should be positive. You should know intuitively it's positive. If you get a negative, probably you messed up somewhere. Okay? Part C, 4f minus 2g. So 4 times f of x minus 2 times g of x. 4 times 4, that's 16x plus 8 minus 6x squared. And as far as I'm concerned, if you leave it like that, you're good.
Wait, not swing.
Yes, I have 3x squareds in this hand, and I have 3 more x squareds in this hand, and if I put them together, I got 6 x squareds. 3 bananas, 6 bananas. 3x squareds, 3x squareds, 6x squareds. Questions? Okay, find the inverse of f of x equals 5x minus 8. First step, y equals 5x minus 8. Replace f of x with y. Solve for x. Add 8 to both sides. Y plus 8 equals 5x. Divide by 5. Y plus 8 over 5 is equal to x. And then for my answer, I swap the x and the y. And I get f inverse of x is x plus 8 over 5. And this is the hard question on the test. There's always one that's really, really hard. This is the really hard question. The inverse of the point 6, negative 5 is negative 5, 6. There's always one question. Questions? Okay. I did the inverse and put it up here because it's easy to do on another sheet of paper and put it in. I can't really do the inverse on the board. So it's kind of hard to see, but you can see where it was traced here. If I do this, you can see there's the inverse. That's what it looks like after you do it. Almost done. Questions on this? And like I said, you just have to know how to do it. Put the diagonal line in, fold it, draw it, rub it. Okay. Performance tasks. There are 2 performance task questions. First one, identify the error. Circle the first error you find in the steps below, then determine the correct solution. Your first error is that this does not match the original problem. That's a typo on my part, but that's actually technically, if you were to do that, do that. Okay. There is actually another error in the problem. If this was actually copied correctly here, there would be another error here. Okay. If you're not sure where the error is, do you have a question or you just, okay. Well, just the way you have your hand, which is fine. You're not sure where the other error is, you can look for it. The other thing to do is, you know this isn't correct, you got to do the problem. Because if there's an error, if I ask you to find an error, there's going to be an error. And the solution that I give you is incorrect. Even if this is copied it over wrong, work this, you will not get that. Okay, so if I do that, 3 root 12 minus 2 cube root 24. So the question I have is this being worked right here? 12, 4 times 3. Yeah. 3 times the square root of 4 times 3, that's good, minus the cube root, sorry, 2 times the cube root, is 24, 8 times 3. Is that what I want to use for breaking down 24? Is it supposed to be 8 times 3? Well, I want it, it's a cube root, not a square root, right? So I do want 8, not 4, because I'm looking for a cube root. So yeah, it is 8 times 3, because it's a perfect cube. 8 is a perfect cube. I want to look for cubes because it's a cube root. Now the square root of 4 is 2. 2 times 3 gives me 6 root 3 minus cube root of 8 is 2. 2 times 2, that gives me 4 cube root 3. And there's my mistake. You cannot combine them into one because one's a square root of 3, one's a cube root of 3. Not just the numbers underneath, but the indexes also have to be the same. These are not like radicals. They cannot be combined into one radical. Okay? That's your answer. That's what would go there. Okay? Yes, if I ever say on a test, find the error, there will be an error. And you will have to work it out and state the correct solution. I'm never going to give you a question where I say find the error and there's no error to be found. Not unless I screw up. I've done that I think once or twice, but usually I don't. Usually I screw it up. And creating one of these problems is actually one of the harder types of questions to come up with. You got to work the problem out correctly, and then you got to go back and make a mistake somewhere on purpose. Going back and figuring out a good place to make the mistake, that's not as easy as it sounds. Okay. Same thing here. Circle the first error you find in the steps, and then determine the correct solution. So given f is 2x, g is x squared plus 4, find g composed of f. So the first thing you want to think is, okay, which one goes inside which? This is the same thing as g of f of x, which means I'm going to take f, stick it inside g. Is that what's going on here? G is x squared, f is 2x. Did I take 2x and square it and then add 4? I did. This is correct. This is f inside g. So where's my mistake? (2x squared) is not 2x squared. 2x squared is 4x squared. And this is a very common error I see students make all the time. It was errors made on a quiz given in here, where you're supposed to square 2x and you don't. My calc students did that on one of the last quizzes I gave them. Literally, I gave them a quiz and they had 2x and they had to square 2x and they gave me 2x squared, not 4x squared. And a bunch of them got it wrong because they did that. Okay? So pay attention to what's going on.